Hello, I'm Manoj Verma from Mumbai, India. I have more than 30 years of teaching experience in chemistry, and I will be teaching you the AS and A level chemistry in a very simple language and easy to follow approach so that students who are weak in chemistry will also be able to understand all the concepts and all the topics and will be able to do well in their chemistry exams and start feeling confident about the subject. Thanks for watching and thanks for being on this channel. Wish you good luck. Now, in this lecture, I'm going to do some problems on chemical equilibrium. So that's going to be the topic. So let's dive in. So as you can see that I have opened a question which is from the March 17 paper 2017. The code is 9701 and the paper variant is 22. So let's start. So in this first part, there is a question which is related to enthalpy change. So as you know, in the AS level chemistry, it will be in the same question, the various sections like the A, B, C, D can be from different chapters. So there is a mix of the different chapters in the same question. Like for example, in this question, we start with a problem that tests your knowledge on enthalpy. But then if you go further, you on the basis of the same question, they switch over to equilibrium, right? On the same question, they have asked questions on equilibrium, right? And that continues with equilibrium. So like, you have to know both the chapters for being able to solve this question. So let's begin. So the first part is the enthalpy, and you can see that they have given you an equation wherein you see that there is 4HCl and O2 gas gives you 2Cl to an H2O. This reaction is carried out at 400 degrees in the presence of a copper 2 catalyst. Use the data in the table to calculate the overall enthalpy change of the reaction. Now what you find is that they have given you the compounds here on the left side, and they have given you the enthalpy change of formation on the right side, but you find that oxygen and chlorine are missing from this table. So you may be wondering, those of you who don't know, they may be wondering, how can we solve this question when the data is incomplete? But actually the reason for that is that the data is in fact not incomplete, but uh, you know the oxygen and the chlorine, they are the elements, right? They are the elements and they are in their standard states. Now they are in their standard states. Standard state means that they are in their normal state at the normal conditions, like oxygen is a gas, chlorine is a gas. So these are the elements in their standard conditions, and there is a convention that the enthalpy change of formation of the elements in their standard states by convention is taken to be zero. So this rule or this convention, you have to remember that for the element the value is zero, therefore these values are not given. And now you have to find out the enthalpy change of the reaction. That means when this reaction takes place, how much heat is evolved or absorbed. So you have to remember the formula that when you have to find out the enthalpy change of a reaction and you are given the enthalpy change of formation, then the formula that you have to use is that enthalpy change of a reaction is equal to the enthalpy change of formation of the products minus the enthalpy change of the formation of the reactants. So here the products are chlorine and water, but chlorine you can ignore because its enthalpy of formation is 0. This oxygen you can ignore, so you have to only worry about the water and the 4HCl, and you have to take down the value from here. So it is twice of the H2O, but this value is for 1 mole. So you'll have to multiply this value by 2. This is about the products. And then you have to subtract the value for HCl, which is minus 92. But because it is 4 moles, you have to do it times 4. And then simply subtract using this formula. So I'm going to show you that how you have to solve this. So when you go on the right side, I have shown you the mark scheme which I have taken from the paper. So see this. So same thing, see, 2 times minus 242 and minus 4 times of 92. So when you solve this, you get minus 116. So that's the answer. So the enthalpy change of the reaction is minus 160. I hope you understood how to solve this question. So now let's go further. And then it says that state the type of catalyst used in this reaction and explain how a catalyst is able to increase the rate of chemical reaction. Now let's see what is the catalyst over here. So you see the catalyst is copper 2 chloride, and you can understand that copper 2 chloride is a solid. Copper 2 chloride is a solid because it's a salt, and salts are solids, whereas the reactants and the products all are in the gaseous state. The catalyst is in the solid state. So when the catalyst and the system, particularly the reactants, when they are in different states, then we call this catalyst as a heterogeneous catalyst. So what is the type of the catalyst used in this reaction? It is the heterogeneous catalyst. That's the answer. Now explain how a catalyst is able to increase the rate of chemical reaction. So how does it increase the rate of the chemical reaction? So the rate of the chemical reaction is actually related with the activation energy. It's related with the activation energy. So if the activation energy is low, then that reaction is fast, and if that activation energy is high, then the reaction is slow. So what a catalyst does, that it provides an alternative pathway, and this alternative pathway has lower activation energy. So when you use a catalyst, the activation energy becomes lower in comparison to the activation energy when the catalyst was not used, and therefore the reaction becomes faster. So that's the answer. I think you understood this. Now we go further and let's see what are the other parts of this question. The reaction was repeated at 1000 degrees and the same pressure. State and explain the effect on the composition of the equilibrium mixture of the change in temperature. So let's see how the temperature has been changed. So what is the temperature at which it was performed previously? It was performed at 400 degrees, and now it is being performed at 1000 degrees. That means the temperature has been increased, right? Temperature has been increased, and now you find out that what was the nature of the reaction. You can see that it had a minus sign. It had a minus sign, look here, minus 116. So it had a minus sign, and it was an exothermic reaction. So whenever you have an exothermic reaction, when you have an exothermic reaction like this, then what happens is that if you increase the temperature, the equilibrium shifts to the left. The equilibrium shifts to the left. So when the equilibrium shifts to the left, what does it mean? It means that if you look at this reaction, the equilibrium shifts to the left like this. So if the equilibrium shifts to the left, it means that some of the chlorine and the water which are present in the system will combine with one another and start changing into HCl and O2. Not all, but some of it. So it means that the equilibrium has been shifted towards the left hand side, which means that the concentration of the products would decrease and the concentration of the reactants would increase. So let's see what does the answer say. Okay, so let's see what does the answer say. We'll just go to the answer right now. Okay, so let's see the answer. It says that shifts the equilibrium, see this, it shifts the equilibrium to the left and decrease yield of the products, chlorine and water. So less product is formed, that means more reactants, because the equilibrium is shifting to the left hand side. So I think you understood this. So this is how it was asked. Then now let's go to the further parts of this question, and it is that, okay, so now let's see, when this is now this is based on chemical equilibrium, and we'll see how we tackle the equilibrium question, which is something which you have not done before in this on this channel. So let's see. Now it says that 1.6 mole of HCl are mixed in a sealed container with 0.5 mole of oxygen and 0.6 mole of chlorine and 0.6 mole of oxygen are formed. So let's see that we have to use the same equation which was given over here. See, this same equation, that is 4HCl plus O2, this same. And see, this is what they have given over here, right? The same. And but they have not written the coefficient down. So please, you see the coefficient and then it will help you. It is 4 and 2 and 2. So let me write that 4, 2 and 2. I think that will help you to understand this question. So I will write here that this is actually 4 and this is 2 and this is 2 and this is the reaction, this is the equilibrium. So the question says that we have mixed 1.6 moles of HCl and 0.5 moles of oxygen in a sealed container. So this will be considered as the initial number of moles. So this 1.6 moles represent the amount of this entire HCl which was present initially, and this is a 0.5 moles of oxygen which was present initially, and obviously initially the number of moles of chlorine and water was 0 because the reaction had not yet started. And then you have to think that reaction started, it went on, and then it reached a state of equilibrium. When it reached a state of equilibrium, obviously the amount of HCl would decrease, the amount of oxygen would decrease, and the amount of chlorine and water would increase and then reach a state of equilibrium. That means after that, it's not going to change. And what they have told you, that what has happened in the equilibrium, right? Let's try to understand what has happened in the equilibrium. So let's see what has happened in the equilibrium. So what it says is that 0.6 mole of chlorine and 0.6 mole of water are formed. That means here you will write that at the time when the equilibrium has been attained, right? So number of moles that is at equilibrium, as you can see here, it's written little in a lighter shade, but this is 0.600 because they have used 3 significant figures and 0.600. This is the amount of the chlorine and the water which is the entire 2Cl2 and 2H2. Don't multiply this by 2. This whole thing represents 2Cl2. This whole thing represents 2H2O. And now these moles are present at equilibrium. So this is not going to change because now it is at equilibrium. So some amount of the HCl and oxygen had been used up, and therefore you will no longer have 1.6 moles and 0.5 moles. Correct? Now you have to look at the stoichiometry. So now when you look at the stoichiometry, then this is 2 and this is 4. That means the amount of HCl is twice the amount of HCl is twice the amount of chlorine. So that means to form 0.6 moles of chlorine, we must use twice the amount of HCl. So 2 times of 0.6, and this amount of HCl is being used up. So the amount which is present at equilibrium will be 1.6 minus the part which has been used. So the part which has been used is 2 into 0.6 because of the stoichiometry. So the amount of HCl which now remains at equilibrium is 0.4. But here you see, here 2 is to 1, that means only half of the chlorine, the amount of chlorine. So half of 0.6, that is half of 0.6 will be used up, and you will subtract that from the initial amount. So what remains now at equilibrium is 0.2. This is what you have to understand. So now at the equilibrium, we have 0.4 moles of HCl, 0.2 moles of oxygen, and 0.6 moles of chlorine, and 0.6 moles at equilibrium. These are the values which will be present at the equilibrium. These are the values which were present initially. So I think you understood how to work this out, because this is where you have to really apply your concept of stoichiometry, and that I did, and I was able to get the answer. Right? So now we understood this, right? All right, so we understood this. So let's go here. So the calculate the amount in mole of HCl and O2 in the equilibrium mixture. So what is the amount of HCl and O2? So you can see this, the amount of HCl and O2 at equilibrium are 0.4 and 0.2. Yes. Now let's go further and calculate the amounts in mole of HCl and O2. So you got that. Calculate the mole fraction of chlorine and the partial pressure of chlorine in the equilibrium mixture. So let's see how we do that part. The mole fraction of chlorine. Now to get the mole fraction of chlorine, what you should do, you should find out how many moles of chlorine are present. Let's see how many moles of chlorine are present. As you can see, the number of moles of chlorine which are present is 0.600. Now mole fraction means that you find out the total number of moles. Now what is the total number of moles? That is 0.4. What is the total number of moles? That means the moles of all this. That means 0.4 plus 0.2 plus 0.6 and plus 0.6. If you add all, you can easily see that it becomes 1.8. So the mole fraction of chlorine is the number of moles of chlorine divided by the total number of moles of all the substances which are present at equilibrium. So this is the mole fraction of chlorine. Now to find out the partial pressure due to the chlorine, you have to take its mole fraction, which you found out over here, and then you have to multiply by the total pressure. So now what is the total pressure? So let's go and check what is the total pressure. So see, the total pressure they have given is 1.50 into 10 raised to 5 pascals. So let's go and put this value, right? Let's go and put this value. So when we put this value over here, see this, This value, when you put, you get the partial pressure due to chlorine, which turns out to be 5.00 into 10 raised to 4 pascals. So that is how this question has been done. So chemical equilibrium, little bit more difficult. You have to solve more problems to understand this. Okay, now we understood this part. Let's go further. All this part is over. Mole fraction of chlorine is done. The partial pressure of chlorine is done. Okay, now look at this. In a separate experiment, an equilibrium reaction mixture was found to contain the four gases at the partial pressures shown in the table. So see, they are using the same reaction which they have given in the beginning, HClO2, Cl2 and H2O. But once again, they have not mentioned the stoichiometry. So this is for the students to remember and put the value. So if you now remember that this was actually 4, this was 4, and this was 2, and this was 2. And this is a new experiment. So they have given the partial pressures of all this. So remember, this represents the partial pressure of the HCl, and all the values are in pascals and all other values are given. Now you know that when we find out the Kp value, we have to do the partial pressure of chlorine raised to 2. So that's why I wrote 2 over here. For water, again, it will be raised to 2, and everything has to be in the gaseous state. And as you know that they were definitely in the gaseous state, as you can see, because otherwise you cannot apply this formula. So this will be squared, this will also be squared. Oxygen will be as it is, and the partial pressure of HCl will be raised to the power of 4. So the values are only given over here. You have to adjust them, raise them to suitable powers and solve it and get the value of Kp. So when you do that, it's very easy to see what value do you get. So let's see this. So they have just put these values and they have solved it, and you get the value, which is 1.05 into 10 raised to minus 5. So this is the value. Now what about the unit? So the unit is Pascal raised to minus 1. Now how did you get that? So let me explain you. So if you look at the numerator, it is raised to the power of 4. But if you look at the denominator, see, if you look at the denominator, right? If you look at the denominator, then how many powers are there? See, there are 5 powers, 4 and 1, 5. So there is one more, that is 4 and 5. So when this 5 will go up, it will become 4 minus 5. So ultimately minus 1 will be the power which is left out. That's why the unit will be Pascal raised to minus 1. Is it clear? Okay. Now the last part of this question is that the reaction is repeated without a catalyst. So what is the effect of this on the Kp? And this is where many students go wrong. A catalyst does not change the value of Kp. A catalyst does not change a value. So how does the value of Kp change, or the value of Kc change? Remember that the Kp and the Kc values depend only on the temperature. So if the temperature changes, then the value of Kc and Kp change. But if if you put a catalyst, or if you change the pressures, or if you change the concentrations, but don't change the temperature, then whether it is Kp or whether it is Kc, the value will remain constant. So what is the answer? Let's just check out. The answer is that the Kp would not change. So this is what I wanted to explain to you. So I think you understood most of it, and we will continue some other time, and then we will try to be more confident about this topic. Thanks very much for watching. If you like the lecture, please give it a like, comment and share with your friends. Subscribe to the channel. Thank you very much.